All right, let's proceed, engineering students, from where we left last time. A short while ago, we were looking at the functional groups alkyne and the benzene compounds. Now we want to look at alkyl halides, or in some cases they can be called haloalkanes. So now we are dealing with a case in which a compound can be called by two ways of naming, two forms of nomenclature. So there are, okay, let me bring it at this time. There are two ways of naming alkyl halides. The substitutive means it's a way, it's a scenario in which you're going to say your halogen, which in this case can be fluorine, bromine, chlorine, and iodine, excuse me, are a substituent on a functional group like an alkane, alkene, alkyne, and the rest. Yeah. Or the other case, you can have a case whereby you've got, you are saying, you have something called a functional class, to which the alkyl group is a substituent on a halogen. So that in this case, the name is going to end with something like the fluoride. If you're going to have a fluorine, it will end with the name chloride. If you're going to have a chlorine, it will end with the name bromide. If you're going to have bromine, and it will end with the name iodide. If you're going to have iodine. Or in this other case, for the substitutive, it means that you are saying your halogen is a substituent on a something. For example, you can say it's a substituent on a hydrocarbon. I think it's good if I can go to examples. I'm just going to bring the case very well. Let's use this simple compound, and then let's see how we can use, probably, let me start with the functional class. In this case, you are going to say the methyl is like the alkyl group, and then the main functional group is the fluorides. So if you're going to have a case whereby this the substituent, this the alkyl group, and this the halogen, then you're going to get a case whereby this functional group, this substituent has got one alkyl, has got one carbon atom. So this is going to be called methyl. Yeah. Are you okay? And this one has got two carbon atoms. So this is going to be called ethyl. Are you seeing that? So there is the ethyl, this is the methyl. Then you're going to leave a space. Then, so you're going to see which halogen are you having here. It is fluorine. So the name is going to end with fluoride. So this will be called methyl fluoride. Have you seen it like that? Methyl, and then there's a space, fluoride. Okay? Now, how about this one? It will be called ethyl, and then there's a space, chloride. Alright? Ethyl, chloride. The other way will be to say, hey, I've got a fluorine, and initially what I had initially was, what compound is that? That compound is called methane. Yeah. And then what I've done is I have replaced one of the hydrogens. I've removed one of the hydrogens, and then I've replaced it with a fluorine. In this case, you are going to say the fluorine is a substituent on a methane. Okay? Fluorine is a substituent on a methane. So the functional group will be an alkane. Are we together? The functional group will be an alkane. So in that case, if you're now going to say the halogen is a substituent on a something like a hydrocarbon, like in this case, then the name, other than the fluoride, I'm going to call it a like, if it's a fluoride, fluorine, I'm going to use the word fluoro. Now in this case, the name will be one, for example, so this will be fluoromethane, or sometimes to make it sometimes to be easily read like a fluoromethane, yeah? But one thing which you need to know is that it is one word. It is one word. One word. As opposed to, in this case, for the functional class, it is two words. Methyl, and then you put a space, then there's the fluoride. Are you seeing the difference? So what happens in this case, there is likely to be a confusion, yeah, as to knowing which one am I going to put, which one am I going to leave, and I mean, which is the most preferred way of naming. What you're going to find out is that halogens, especially chlorine, fluorine, and especially chlorine and fluorine, you can have a hydrocarbon like a methane. It can contain more than one halogen. It can contain more than one halogen. For example, you can have such a compound. It can contain another fluorine, or it can contain two chlorines. So for example, I can have, let me put it in red, yeah? I've got a chlorine, then there is the carbon, then there is the fluorine, and then there are the hydrogens, yeah? Alright? Can you see what I've done? There's the chlorine, there's the carbon, then there's the fluorine, then, so this is a methane, but it contains a chlorine and it contains a fluorine. So if you're going to use functional class nomenclature, then you're going to get stuck. Are you going to say it is a chloride? Are you going to say it is a fluoride? So what scientists have said is that in such a scenario, the substitutive nomenclature becomes handy. So when you have at least more than one substituent, you're going to see that the substitutive nomenclature is the preferred way of naming. So that this one, it will be called chlorofluoromethane. Yeah? Chlorofluoromethane. Yeah? Chlorofluoromethane. Is it ringing a bell? Yes. You've dealt with some compounds called CFCs, fluorocarbons, yeah? Like the ones which pollute the atmosphere. They are produced from the fridge and the rest, yeah? They used to be in the fridges, yeah? Chlorofluorocarbons, yeah? So I think you can see the name, yeah? Chloro, I mean, something like you're using the substitutive nomenclature. So this will be called chlorofluoromethane, yeah? But if you have only one functional group, then you're going to call it something like that, that one as the alkyl group, and then something like, in this case, it contains only one functional group, like the chlorine, yeah? So you're going to call it ethyl chloride, yeah? So going forward, this substitutive nomenclature is the most preferred way of naming. So you're going to hear substitutive or functional class nomenclature, yeah? All right. So okay. Let me delete this. Okay. So let me look at that compound which was so this one was ethyl chloride, but I'm going to call it chloroethane. Now, what if now I was to have another functional group? For example, if I have this okay, so what I've done is to add a fluorine in the structure. So want to distinguish this structure with another isomer like this one. Are you seeing that? So this is an isomer of this, but they are not the same structure. So it is important to now start adding numbers to be able to know exactly the position of the substituent. So what you're going to do is to use the alphabetic way in which in this case there is a chloro, and then there is a fluoro, yeah. So the C comes before F. So in this case, I'm going to start numbering. This is carbon number 1, this is carbon number 2. So in this case, that is carbon number 1 and carbon number 2. Yeah. So what name are you going to give the first hydrocarbon? You're going to call it 1 chloro 2 fluoroethane, yeah? All right. How about the second one? It will be 1 chloro 1 fluoroethane. And with that one, you're going to use that nomenclature to go to more complex ones. Yeah? Perhaps I may need to introduce at this point. Yeah? Let me just try to bring a slightly more complicated example, and I think we'll proceed from there. Let's try to look at a more complicated example. So there is a carbon, 2, 3, probably 4. Probably I'll put a CH3 there. I'll put a hydrogen, and then I'll put probably I'll put a bromine there, and then I'll put maybe I'll put an iodine there, and then the rest I'll just put a hydrogen. All right. So this is a 1, 2, 3, 4 carbon atoms. So it is a butane, and then it has a methyl substituents. Let's look at the substituents. Perhaps let me circle them. There is a methyl group, there is a bromo, and then there is an iodo. So there is a methyl, there is a bromide, a bromo, and then there is a iodo. Okay. So that tells you need to understand from which side you're going to number this structure. To give the lowest numbering, the best thing is to start numbering from here, because that one is going to give the carbon numbers the lowest. For example, if I start numbering from here, the first substitute will be on carbon number 2, like but you want to put the ones for the alphabet the lowest number. So I'm going to start number from here 1, 2, 3, and 4. So that will tell you the nomenclature for this, the naming for this structure. It will be 1 bromo. So the bromo is on carbon number 1, iodo is on carbon number 3, methyl is on carbon number 2. So which is the next functional group am I going to put? After B, I'm going to put I, and then lastly I'm going to put M. So it will be 3 iodo, and then there will be 2 methyl. Oh, because of the space I'm going to put a space dash, but the name is continuing, and then I will put the name of the structure as butane. Yeah. So it will be 1 bromo, 3 iodo, 2 methyl butane, all as one word. It's just that I'm leaving it there, so I'm just put it on the second line. Yeah. So have you seen 1 bromo, 3 iodo, 2 methyl butane? So with that, you can be able to put as many functional groups, because you've seen if you've got alkyl groups, how you put the priority. Yeah? Ethyl, methyl, propyl, and the rest. So the point which you want to drive at is this. If you have halogens and you have alkyl groups, there is no one group which has a higher priority. The thing is, you need to number the substituents as to give okay, the substituent should have the lowest numbering, but also the ones of the lower alphabet like A, B, C should come first before the others. So that will dictate on the direction in which from the side which are going to start numbering as number 1, yeah, of the chain. So with this one, you'll be able to look at many examples. Okay. So let me mention something about the ones containing the benzene group. Yeah. Okay. So there is CH3, and probably there is a bromide group there. Yeah. Okay, so I can have a Cl, I can have a Br, and then probably I can have a what? Probably I'm going to have a CH3 here. Alright? Okay? So this will be the main functional group is benzene. So it means that the name is going to contain benzene. But now, how are you going to number these ones? Excuse me. There is the bromo, and then there is the methyl. B comes before M. So I'm going to start from here. 1, 2, 3, 4, 5, and 6. So this will be 1 bromo, 2 methyl benzene. Now, let's see how we're going to number this. B is going to come before M, so I'm going to start number 1, 2, 3, 4, 5, and 6. So what name am I going to get this one? 1 bromo, 3 chloro, 4 methyl benzene, yeah? As one word. Okay? So this is how you're going to be numbering if you've got a halogen on a benzene, or in this case we had the halogen on a straight chain, which you're going to call so this is going to be called aliphatic. You're going to use the word aliphatic. It means you're talking about a hydrocarbon which does not have a benzene ring. So this will be called aromatic. Aromatic halide, yeah? So this will be called aliphatic halide, yeah? So it's it's a halide, but it's on a chain which does not have a benzene ring. So you're going to hear this word aliphatic, or you're going to get the name of aromatic. Yeah. So I think there was a word there. There's a symbol there which I had drawn, and I think I need to bring it out before I wrap up this this section on the alkyl halides. Oh dear. Okay. Good. And this is something which you are going to be picking up from now, going forward. So you're going to introduce a letter which the scientists, the chemists, they looked at the periodic table and then they saw, hey, there is this letter in which there is no element attached to it. So they just use the word R to represent the general form of an alkyl group. So for example, if I've got something like, I say Rx, yeah, Rx. I'm saying here I've got, this is a halogen, e.g. F, Br, Cl, or iodine. Yeah, that's a halogen. And then this one you can say this is methyl. This can be Ca3. That is, you can say this is methyl, ethyl, propyl, butyl, etc. Yeah. So you're going to encounter that letter R as to represent any alkyl group. It's just a general form of an alkyl group. Yeah. R is the letter for a general alkyl substituent. Yeah. So in this case, you're just going to say, so if I'm going to have something like a benzene, sorry, let me draw it a proper hexagon. And then I say R, I say I've got a benzene group and then there is an alkyl group attached to it. So you can be more specific and say, maybe I've got something like a benzene, or maybe I can have something like 1, 2, 3, 4. Okay? Can you see in this case, this is just a general R. It can represent something like a structure whereby there's a benzene group and then it's attached to a methyl group, or a benzene group attached to a butyl group. Yeah. So this is your R group and this is your R group. Yeah. It's like a shorthand notation. So will you remember that? R is a symbol for an alkyl substituent. Now, do you say that you can put X when you do not want to specify whether you're dealing with a fluorine, bromine, chlorine, or iodine? Yeah. Yeah. So later we'll be looking at the physical properties of alkyl halides and also their uses later. But now we are actually dealing with the nomenclature of alkyl and the benzene or the aromatic halides. Yeah, I hope you've really enjoyed this section. So in a short while we'll be looking at the nomenclature of alcohols, and then we look at other functional groups like ethers, then aldehydes and ketones. Yeah, I hope you've really enjoyed this section. So thank you very much. Okay.